Hello again, Year 11, and welcome to your second physics lesson for this week. This lesson is on the ideas of speed and velocity and should really be a revision exercise for you because you'll either have studied this in maths or in Key Stage 3 in science as well. So it should actually be quite straightforward for you. So before you start the lesson, make sure you've got the equipment you need. In this case, you will definitely need a calculator, some paper, pen, but if you feel the need, a pencil and a ruler as well. As you're going through the video lesson, it's really important not to rush. And so if you feel you would like to make notes from a slide, just pause the video when you want to. However, when you see the yellow star on a slide, this means there's going to be work for you to do, and you will probably need to pause the video to give yourself enough time. Well, this lesson is designed to take it approximately 45 minutes, and that includes the time whilst you've got the video paused. So I don't really want you to take any more than 45 minutes. Well, the start of any lesson requires a title, so let's put down the title Speed and Velocity, so pause the video whilst you're writing. So here's your starter. You've got 6 different land-based animals there, and I'd like you to consider how fast you think they can move and rank them from slowest to fastest. Pause the video, please. So let's see how you got on. The snail is the slowest, then the tortoise, then the hamster, then Usain Bolt, then the horse and the cheetah. And if you know your natural history, you should know that the cheetah is the fastest land-based animal we've got. There are birds that can move faster than a cheetah, but not whilst running, only whilst flying. And so on that second half of the table there, I've given you the estimated speeds in meters per second. So that little snail there can only do a few millimeters per second, where a tortoise can do about 5 centimeters, maybe up to 10. A hamster can do 2 meters in a second. Usain Bolt, when he's running at his fastest, can do 12 meters per second. The horse is 13, so not much faster than Usain Bolt. In fact, they could probably canter along at a similar speed for a short period of time and then hit the cheetah there at 27 meters per second. So the objectives for today is to make sure that you're able to quote some standard average speeds required by your exam board. Make sure that you're happy with the equation for calculating speed and doing calculations with it, making sure you can rearrange and use the equation for speed and velocity, and just again make sure that you are very comfortable with the difference between the terms speed and velocity in physics. So let's have a look at some standard ideas. So I'm going to put a few units up and I want you to consider what they have common. So I've got a car travelling at 70 miles per hour, a continent moving at 3 centimetres per year rather, and a bullet travelling at 330 metres per second. Now that continental one in the middle there is due to the fact that the plates on this planet are moving. So the sort of great big slabs of rock that we call continental plates are in constant motion. And we are actually moving away from America at a rate of 3 centimetres per year. America's getting further away. And that bullet there, that speed is basically the speed of sound, which is why a bullet makes that cracking sound as it's travelling, because it's approaching the speed of sound. So if we have a look at those 3 things, the thing they have in common is they all have a measure of distance and they all have a measurement of time. And that's because they're all units of speed. All 3 of them are totally acceptable units because they're measuring the rate of travel for different objects. So you already know this, but let's just make sure we plug all of the gaps. If you're going to calculate speed, you need to know 2 quantities. You need to know the distance travelled by a moving object, and in physics we normally measure that in meters. And we then also need to know the length of time it took to travel that distance And again, in physics, we normally measure that in seconds, because speed is how quickly an object covers a certain distance. So before we start on the maths, let's have a look at those everyday speeds that you're expected to know by your exam board. It's also, a good thing to be able to think about. So you're expected to know 6 stated average speeds. You've got 3 to do with a person's movement, and then you've got 3 different modes of transport. So your standard car, train, and plane. The yellow star is up there because I'd like you to spend a minute or so trying to memorize those 6 values. And whilst you're doing that, I want you to think about what you notice about the speeds linked to the human activity. So pause the video now. So whilst you were trying to memorize them, did you notice that the human activities just double each time? So you only have to learn the first one. If you can learn that an average walking speed is 1.5 meters per second, you just have to double that for running speed and then double that again for cycling speed. Not so easy for the plane, train and car, so those I'm afraid you're just going to have to learn off by heart. But I suppose you could look at it and say, well, a plane is 10 times faster than a car. But it's up to you, but you do need to learn them. Okay, so while you're listening, I'd like you to put down the 6 things there, and next to each one, without cheating, without looking back on the video, can you write down the speeds? Pause the video. How did you do? So the aeroplane is the fastest one, so that's your 250 meters per second. Cycling is your fastest human activity, so that's your 6 meters per second. Train at 55. Walking, that's your slowest one, so that's the one I need you to learn, that's your 1.5. Your car at 25 meters per second, and then running in there at 3. So again, really important that you understand those are the speeds you're expected to know off by heart. So let's get down to the business of calculating speed. Most of you should be able to quote this equation by now, that speed is equal to distance travelled divided by time. In physics, the unit for speed is meters per second, and that's your distance divided by your time. So we need to measure distance in meters, time in seconds. And so if we're thinking about a cheetah, if we measure a cheetah covering 80 meters in 4 seconds, 80 divided by 4 gives it a speed of 20 meters per second. Now, some of you quite like using calculation triangles, so you've got a triangle up there. What I'd like you to do is spend a few moments seeing if you can fill it in correctly, because sometimes it does help in an exam just to be able to jot it down in case you need to use it. So pause the video whilst you do that. So let's see how you get on. So the thing to remember about calculation triangles is if something is divided by something else, so in this case distance is divided by time, in the triangle time needs to be at the bottom and distance needs to be above it. If it's not, that's not the divide by. So that leaves the third space there to be speed. So if we look at our triangle, we get the fact that speed is equal to distance over time, or distance divided by time. But if we wanted to calculate distance, we've got speed times time next to each other down there. And if we wanted to know how long it took to travel somewhere, we've got to do distance divided by speed. Again, hope you were listening, because now what I'd like you to do is to complete the word equations for those 3 factors. Pause the video. Okay, so if you are using your calculation triangle, or if you're able to rearrange equations using your mathematical expertise, time is distance divided by speed, distance is speed times time, and speed is your standard one there, distance divided by time. You need to be able to use all 3 comfortably. And again, this is an equation that is not given to you on the exam paper. They expect this to be part of your standard recall of all of the formula that you're supposed to know, especially as this is a key stage 3 thing that you learnt. You learnt speed as distance divided by time in year 8. Not sure what year you learnt it in year 9, or in maths rather, but it's no later than year 9. So you should be able to do this. So just to remind you on calculation rules, when you're approaching a question in your exam paper, or even sort of when we're asking you to do it, it's important to train yourself in the way to set out calculations correctly. So I've got a question here. What speed is a fly travelling at if it covers an 8-metre room in 1.3 seconds? Rule number 1, you must always write down the equation you're going to use. Now you can write it as a word equation or a symbol equation, but it needs to be there. So the examiner is totally clear what maths you're about to do. Now, sometimes you need to check the data in your question is in the correct unit. You might have to convert it, but that's another skill that we need to practice at another date. I will be asking you to do a bit of that today, though. So in this case, the distance is already in meters, which is our standard unit. The time is already in seconds, which is a standard unit. So you just need to do 8 divided by 1.3. You do the maths, you write down the answer. And then your fourth step, really important to write that unit. If you just write 6.15, you haven't written the speed. You've just written a number. The unit makes it the speed. So I can't stress more the fact that every single calculation, your final answer should always have the unit of the measurement you've been calculating. So without further ado, time for you to have a go at some questions. Now you need to look carefully at some of them because I've mixed up a couple of units, and you're going to be required to rearrange that speed equation. Question 6 is your high-level challenge question. It actually requires a lot of thinking. So I reckon you're going to need at least 10 minutes to get these 6 questions done. So pause the video whilst you're working. Question 1, let's see what you did. Question 1 was straightforward. You had a speed calculation, so speed equals distance divided by time. There was no unit conversions required, so you simply had to do 45 divided by 9, and you end up with 5 meters per second. Question 2, they asked you to calculate how long, so the time it took. And so in that case, time is distance divided by speed. Again, I've written the equation down I'm about to use. I then plug in the numbers, so my distance travelled was 70, my speed was 100 meters per second, and so the time it took was 0.7 seconds. But again, that unit there for seconds is critical. Question 3, again, your time needed to be calculated, but you should have spotted that you had 2 different units of length there. The speed was in kilometers per second, whereas the distance was in meters. So the first thing you had to do was convert that speed. So I've converted it to 10,000 meters per second. Then I can put it into the calculation and do 10,000 divided by 200 to give me an answer of 50 seconds. Question 4 asked you to calculate the distance. Now this time you didn't have to convert the units because it was in kilometers per hour, and the time taken to do the journey was in hours as well. So all you had to do was multiply the 2 together. Now I'm not sure if I got the correct unit there. Should it be in kilometers or meters? I need to look back at my question to find out. So let's have a look there. No, we're all right. It is in meters. Now, question 5, the distance, speed times time. Again, you just had to put the information out of the question there. Speed at 410, times at 5.7, and you ended up with 2,337 meters. Again, unit critical. Now, question 6 was your challenge. Okay, So we've got a car traveling in a 30 mile per hour zone, and it covers 63 meters in 3 seconds, and you're asked to consider if it's speeding. Now, what we've got there is a total mix-up of units, and so we need to do some conversion. So, first of all, we need to convert that miles per hour into meters per second. So, first of all, if we've got 30 miles, according to my information at the top there, 1 mile is 1,609 meters. So 30 miles is going to be 48,270 meters. Now we need to convert it into meters per second by dividing by 360, because that's how many seconds there are in an hour. So we end up converting 30 miles per hour into 13.4 meters per second. So that's our reference number. Next, you need to calculate the speed of the car. So you're told that it's managed to travel 63 meters in 3 seconds. And so that gives it a speed of 21 meters per second. Comparing that to the reference value of 13.4, the car is most definitely speeding. So quite a complicated task there, lots of things to consider. High-level maths, you've got unit conversions, which you're expected to be able to do yourself. However, that 1 mile equals 1,609 meters will be given to you if it's required in a question. But you're more likely to be asked to convert kilometers per hour into meters per second. So I hope you did okay with that one. Make sure that you've spent time understanding how that was done. So short brain break here, 2 multiple choice questions for you to have a go at. Pause the video. So how did you get on? So typical walking speed, remember walking is the slowest one, so that's your 1.5. Your typical cycling speed, now that's the fastest, so we have to double it and double it again, so we end up with 6 meters per second. And here's an exam question. I want you to read through it and see if you can work out what needs to be done. Pause the video. Right, so the important thing here is it's the words that are going to throw you, not the maths. So you're told the thinking distance is the distance travelled by a car during the driver's reaction time. And you're told that the car is travelling at 13 meters per second and the driver's reaction time is 0.6. And you're asked to calculate the distance. So what they wanted you to remember there is that the distance is always going to be the speed an object is travelling multiplied by the time it's travelling that speed at. So we've got 13 multiplied by 0.6, which gives an answer of 7.8. Now they were nice enough to give you the unit in the answer, so the distance is simply 7.8 meters. And so that's the distance a car will travel during a driver's reaction time. So moving on to that word velocity. Now we've done quite a lot of work on this idea of different types of unit and how they're defined. And in your previous physics lesson, you looked at the link between distance and displacement. So now let's do the same for speed and velocity. Velocity and speed are linked. They're both a measure of how fast something is traveling. But speed is simply how fast you're going. And so speed is a scalar measurement. All we're interested in is the value. We're not interested in a direction. Whereas velocity is how fast you're going in a given direction. And so if we're quoting a velocity, it needs a unit of speed, but also a direction. And if you remember from your previous, anything with a unit, a size, and a direction is a vector. So velocity is a vector because it has both a size and a direction. So you really need to understand that velocity is just a physics term. We don't usually use it anywhere else, but the important thing there is it's got a direction. So I'm going to illustrate this in my little PowerPoint here. So I've got my car there, and it's going to do a tiny bit of a journey. So watch my journey. So it's gone along the road and then down round the corner. What is the velocity at 3 and why? So pause the video, have a think about it. So you should have noticed that on the table, we've got speeds given to you. So at position 1, that's this one here, the speed was 30 meters per second. But the velocity is stated at 30 E. Now that E stands for east because it's traveling across your page. And again, on your previous physics lesson, if you're going right across your page, we consider that to be the east direction on the compass point. It then reached point 2, and at point 2 it slowed down because it's about to turn the corner, and its speed was at 15 meters per second. But because it was still going forward at that point, its velocity is 15 east. So what did you decide we needed to write down for the velocity at 3? On my table here, we've got a speed of 30, but its direction is now going down the page. And again, from our previous lesson, going down the page is considered to be in the south direction. So that is 30 meters per second south. So the velocity there and there are different, not because the value is different, but because the direction is different. And that's a critical thing about velocity. The number might be the same, but the direction could be different. And that's what makes it a different velocity. So how is velocity worked out? I want you to look very carefully at this equation. What is different compared to the speed equation? So have you noticed? Instead of saying distance, it says displacement. And that's because displacement is a vector quantity. And when you divide it by time, you get a vector velocity quantity. So those two things are linked together. If we looked at the speed calculation, speed equals distance divided by time, and speed and distance are scalar. Here we've got velocity equals displacement divided by time, and so we've got two vectors kicking in, right? So it works exactly the same as speed, but the displacement there is a vector. So let's see what that actually means. So I travel every day from Sheffield to Worksop, and then I have to turn right onto the A60 to travel down to Worksop to actually get to school. Now that Sheffield to Worksop road is a wiggly, windy road. And so as I travel traveling the wiggles and turns, that I would measure as my distance. So distance is every little inch of that route. But if I'm going to do my displacement, I iron out that wiggles into a straight line. So remember displacement from our lesson before. Displacement is the shortest straight line distance from start to finish point. So my displacement is a straight line. It's going to be shorter than the true distance, but I need to say what direction I'm traveling as well. I would like to think I travel to school in a car like that, but I really don't. So what I'd like you to do is have a go at some calculations. The calculations are as straightforward as your speed calculations, but I need you to think very, very carefully about what you're going to write on your answer. So pause the video, have a go. Okay, so let's see how you got on. Question 1, you're asked to calculate the velocity, so that's the displacement divided by the time. So quite straightforward maths there, and we end up with 1,950 divided by 10. We get an answer of 195. We need to make sure that we understand that that is a velocity, so we have to give that speed unit there as meter per second, but without the word north, you've only written a speed, not a velocity. So you must make sure you refer back to the question to find the direction the object was traveling in. Same applies to number 2. You're asked to work out the displacement. Now the displacement is velocity times time, so that's 4 times 5. Didn't need to convert the units there because it was in kilometers per hour and the time was in hours there. So we end up with the answer of 20, and in this case that's 20 kilometers, but because it's a displacement measurement, we need to give that direction. It's 20 kilometers east. Now this is the one that can catch people out sometimes, but you're asked to calculate the time. So that in that case, you're doing displacement divided by velocity. So we've got 680 divided by 340 to get the answer 2. Now, because the speed there, or the velocity there, was given in meters per second, then the time is in seconds. But notice there's no direction after there because time is not a vector quantity. So even though it's in the velocity equation, it is not a vector quantity. So if you calculate time, you must not put a direction there. If you do, it's wrong. So just to reiterate here, we've got velocity and displacement are vectors, and so need a distance and a direction or a speed, but time isn't a vector. We just have to give the unit in seconds there. Right, so if you were listening carefully through all of this, you should be able to spot that these 5 statements are incorrect. So what I'd like you to do, so you practice writing your science as well as reading it, I'd like you to copy out each statement but correct it. Now, one word or a phrase needs changing to make the sentence right. Pause the video. Right, so that's sentence number 1. If something's got magnitude and direction, it must be a vector. Speed is a scalar quantity and velocity is a vector quantity. Now this should be easy for your brain to remember because speed and scalar are the 2 S's. Velocity and vector are the 2 V's. There should be no excuse for mixing those 2 up. When it comes to speed, it's got to be distance divided by time because it's scalar, not vector. When it comes to velocity, it should be displacement divided by time. And just picking up on that idea of displacement, it's the shortest straight line distance from the start to the end of a journey with a direction. But the most important bit is it's that shortest straight line distance. Now, if you haven't used your whole 45 minutes to do this lesson, there is a follow-up activity for you to have a go at, which is more maths to do with speed. Good luck if you want to have a go at it. And so it's now goodbye from me for now.